So this is an extension of the graphing sine and cosine functions that we've already learned. And we graphed really basic ones. We only had amplitude changes, sometimes we had a reflection, and then we graphed just basic sine and cosine. Well, every one that we graphed so far has always had a midline at 0, but that's not always the case. We're not going to discuss what are called phase shifts for Algebra 2. We're going to save that for next year. But we are going to discuss what are called vertical shifts. So at the top of your paper here, and this is a homework assignment, but we're recording it anyways because it's a little new. I want you to write this formula down, y equals a, and then we'll just use sine function for now, and then times b theta, that's the formula we've seen so far, but there's really a plus k off to the side. So far, up until today, this plus k part has been 0. This represents the vertical shift. Remember, k is always how far up or down the function has traveled. And it does exactly what you think. So if it says plus 2, it means up 2. So when I look at this first question, I do see a plus 2 off to the side. So that means everything was shifted up 2 units, including the midline, the minimum, and the maximum. So what I do when I graph these ones with vertical shifts is I draw where my new midline is, which I'm going to use this neat little feature. So now it's up here at 2. And then I'm going to sketch in a maximum and a minimum line. So I notice our amplitude is 4, which means from the midline we're going to travel up 4 units and down 4 units. So going up 4 units, we're talking up here at 6. And then traveling down 4 units, we're down here at -2. So you're still going to see that wonderful symmetry that these graphs always have in every direction, but vertical in particular. Okay, that was a little messy, sorry. The other thing that we see on this worksheet that we haven't seen yet in most of our Algebra 2 classes, that's already done for you. What I have you do is find the period, find the quarter points, mark them up accordingly. Well, here we do that. I notice that in the sine function, there is a b value of 1, which means the period is not going to change. The period is going to stay as 2 pi, because 2 pi over 1 is still 2 pi. So I still want you to find the quarter points. So you still take your period and divide by 4. So we're supposed to mark every pi over 2. So what I would like you to do now is just kind of off somewhere to the side here. I want you to write, we're going to write 5 ordered pairs. I know it's quarter points, which makes us think about 4 ordered pairs, but remember, we always have that starting point. So, oops, that's not 5, Abruzzo, one more. This is a sine function, so it's supposed to start at the origin is what we always said, but remember, everything got shifted up too. So our sine function is actually going to start right here, and this is the ordered pair 0, 2. And then, so this is going to be 1 pi over 2. This will be 2 pi over 2, which is just pi. This will be 3 pi over 2. And this will be 4 pi over 2, which is just 2 pi. So then for the y value, just remember the pattern for sine. It starts in the middle and then goes up to the maximum. So at pi over 2, it went up to 6. And then it's going to come back down to the midline. So at pi, it's back to 2. And then it's going to go to the minimum. So at 3 pi over 2, it's down to -2. And then 2 pi, it's back at the midline, which is 2. So there's still a bit of a pattern. It's just a little harder to come up with a pattern without thinking about the graph really hard. And then, of course, don't forget the... I'm going to ruin this whole question here at the end. Okay. That was bad. Use your imagination. And it does say just graph. We're only going to graph 1 cycle, if that's okay with everybody. I figured you'd be all right with that. So some new stuff here. We're shifting everything up or down. We're still finding quarter points and periods and all that good stuff. But now I want you to come up with the 5 ordered pairs in ordered pair notation. That's a new thing for us. We didn't usually have you do that, but we're going to start doing that on this worksheet. So here, this cosine graph is -2 without in front of the function, but I could just as easily write it back here if it bothers you. That is a down 2 shift. So our midline is now at -2. There we go. And then, again, we have an amplitude of 4. So traveling up 4 units will bring us up here to 2, positive 2. And then going down 4 units is down here at -6. Pretend that was totally well done. Alright, so again, still need to find b, period, all that good stuff. So this is really similar to that question. The period is still going to be 2 pi. The quarter points are still going to be pi over 2, because you divide 2 pi into quarters. So the new thing for us is coming up with these 5 ordered pairs. So they're going to look theta values, the first part of the ordered pair. So we're still going to have 0, comma something. I'm going to run out of room, so I'm going to write them side by side here. And then we're going to have 1 pi over 2. And then we're going to have 2 pi over 2, which is pi. And then we're going to have 3 pi over 2. And then we're going to have 4 pi over 2, which is 2 pi. Alright, so this is cosine this time. Cosine is supposed to start at the maximum line instead of the what we used to call the origin, or the midline. So this ordered pair is at 0, comma, positive 2. And then at pi over 2, it's going to travel down. Now be careful, everyone tries to go to this axis. We got to go down to the green line here. So the middle, so pi over 2, it's down to negative 2. And then keep going. Pi, it's all the way down to the minimum, which is negative 6. And then 3 pi over 2. Now watch your lines. This is why I encourage you guys during class to use highlighters to mark up your lines, because it's a little harder to miss a highlighter line, right? 3 pi over 2 is down here at negative 2, and then back up to 2 pi at positive 2. And then, of course, we're drawing the world's ugliest cosine curve. Oh, gosh. This was just, you know, I just ruined it right off the bat, and then I lost my confidence. Eraser. There we go. Yeah, whatever. Okay. It's supposed to be the weird. Made sense, but I was like, oh, sure. Alright, this next one, sorry about this, I got a little cold here. Let's go ahead, let's do number 5 together. And then I'm trying to look ahead in the worksheet. We'll do one of the fraction ones together, and then we'll call it a day. Alright, so you're going to finish the whole worksheet by yourself, of course. We have a midline at 1, everything shifted up 1. Not what I wanted. 1. Green line. Oh, I did pull that. Alright, 1. And then we have an amplitude, this time of 3. So going up 3 units will bring us up to 4. And then down 3 units will be at negative 2. Alright, here we go. We're going to be graphing sine. I need to figure out the period, though, because it's all been messed up. We have a b value of 4 this time. So the period is 2 pi divided by b. So the period is pi over 2. And this is why I don't like when they give me graphs, because from 0 to pi over 2, we're going to have to fit in an entire sine curve. This is going to be like the world's ugliest sine curve. Here we go. Quarter points. Take the period, and you divide it by 4. Well, the way we divide fractions is we multiply by the reciprocal of the second fraction. So let's multiply by 1/4. And that gives me pi over 8. So we're going to have to mark every pi over 8. Alright, starting at 0 though. For algebra 2, we are not going to do what's called a phase shift, which is moving it left and right. So you're always going to start at 0. So theta. Alright, 1 pi over 8, 2 pi over 8, which is pi over 4, 3 pi over 8, and 4 pi over 8, which is pi over 2, which is the end of the period, so yeah. And then what I like to do is draw in the points, those quarter points, and then I just figure out what the point is after that. I'm more of a visual person. You guys know this about me by now. Alright, so we have sine function, which starts at the middle. So 0 is going to start at the midline, which is a 1. And then at pi over 8, now they don't mark pi over 8, but it's halfway between 0 and pi over 4. So you have to go up to the maximum line in between here, and that would be at a 4? And it's going to come back down to the midline at pi over 4. Ooh, it's a very close call here. This is going to be bad. And then 3 pi over 8 would be in between pi over 4 and pi over 2, because this is 2 pi over 8, and this is 4 pi over 8, so it's right in the middle here. Plus, you can tell from the pattern we're counting every half block. So that was what, at negative 2? And then pi over 2, we're going to come back to the midline at 1. So, it's really close to go. Alright, I did not do a very good job of graphing that. But you see what's happening here is, this is why we don't really like when they give us coordinate planes, because then I have to scrunch in a little sine curve, like wherever they determine the labels to be. But it is nice for you guys to see what the b value does to the period of the curve. So normally it stretches all the way out to 2 pi, but this guy got shrunk way back. So very close call. All right, we're going to move on to one of those fraction ones. Remember theta over 2, we pull the 1/2 and the theta separate from each other. So we're going to rewrite this as sine of 1/2 times theta. So this 1 plus can be written in the back if it bothers you, but it's 1 plus sine of half theta. So the b value is 1/2, which means I have to calculate the period because it's not 2 pi anymore. So 2 pi divided by 1/2, remember, instead of dividing by 1/2, we could multiply by that reciprocal, which is times 2 over 1. So the period is actually a 4 pi, which makes quarter points pretty nice. Take that period length and quarter it. So we're going to be counting off every pi. So, oh, you know what I forgot to do though? Forgot to mark my lines on my curve. Let me just get these down real quick and then we'll go back and start graphing stuff. Alright, always starting at 0 for us, and we're going to count every pi. So 1 pi, 2 pi, 3 pi, and 4 pi, which is the end of the period. Alright. Okay, back to a little graphing here. My midline is shifted up 1, so we have a midline at 1. And you know what? I'm going to use this tool to maybe graph my max and min. So, annoying. Your amplitude is only 1. That's why I chose to. I'll see, and I still screwed it up. All right. That was. I need to move these down. Let's see. Maybe I can shift it down with my. Oh, too far. There we go. And then this guy is moved up a little. Don't you wish you had that on your paper? Excuse me, I'm sorry. Alright, so we're graphing sine. Starts at the midline, which is right there, I think. Although I can't even read it. I think that's at a 1. So 0, 1, and then it's going to go, sine goes up next. So at pi, it's going to go up to the maximum line, which is at 2. And then at 2 pi, it's coming back down to the middle, which is at 1. I don't know what that was. Let's try that again. 1. And then at 3 pi down to the minimum, which is at 0, height of 0. And then 4 pi back to the middle, which is at 1. And then we get to draw the curve. Ooh, that was beautiful. Thank you. Alright, so that's about all I'm going to do for you. I did about half your homework for you. You're welcome. We're going to take our knowledge of the cosine and sine functions with vertical shifts, and we're going to use this to figure out some trig modeling on our next lesson. And that's actually our last lesson of the year, once we get to next week.